Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question, construct binary tree from Inorder and Levelorder traversal. So we'll be given two arrays which will be representing Inorder and Levelorder of a binary tree. And what we have to do, we have to create a unique binary tree out of given Inorder and Levelorder. So let's move to our tree. So this is our binary tree, and what we'll be given Inorder traversal and Levelorder traversal, and we have to construct this binary tree using these two arrays. So I hope you are aware with the Inorder traversal. Like if we are traveling from here, then firstly Inorder will be 3, then 7, then 5, then 6, then 11, and then 2, after 2, 4, after 2 it will be 15. How? After 2 we'll take its left child, there is no left child, then 15, then 9, then 4, after 15, 4, then 9. So this is our Inorder traversal, and the Levelorder traversal for this will be 2, then 7, 15, then 3, 6, 9, then 5, 11, 14. Okay, so we'll be given these two things and we have to construct this binary tree using these two things. So we have also construct the binary tree using Inorder and post order, and we have also done a question where we have constructed binary tree using pre-order and post order. So if you are new to construction of binary tree, then also watch the video of question construct binary tree using pre-order and post order. See, after watching the question and solution of this video, then you will understand the solution of this question more easily. Okay, so if you haven't watched that video, also watch that video. So in this question, what we'll be doing, see, we know that in order the path we have traveled is left, root and right, and in Levelorder the very first node is the root node. So we will use this property while we'll be constructing our binary tree. So first understand some terms like starting index of Inorder, ending index of Inorder, and Levelorder starting index and Levelorder ending index. So ISI will be, initially it will be 0, it will be 8, and also this will be 0, this will be 8. Okay, and our root is the starting value, that is 2. This is the root, and what will, if we'll think of the approach, then what we'll do, see, we from this property we know that the 2 is the root. 2 is the root in our binary tree. So what we'll do, we'll search for this 2. We'll search for this 2 in our Inorder. So when we'll search this 2 in our Inorder, we'll find our 2 over here. So we will mark this position. We'll mark this position as IDX. So at fifth index we have found our root. So we have used the property of level order. Now after finding our root value in order, we'll use the property of in order. What does the property of in order says? It says if I have found our root value, then left elements belongs to our left subtree and the right elements belong to our right subtree. Like we have found our root value, then the left elements, that is 3, 7, 5, 6, 11 belongs to our left subtree, and the right side elements 15, 4, 9 belongs to our right subtree. See, I'm not saying that the order will be same, but we have found this thing that the left elements will belong to left subtree and the right elements belong to right subtree. If you want to cross check this thing, then you can check from here. It is containing 3, 3, 7, 7 is present, 5, okay, 6 and 11, 6 and 11. So this belongs to left subtree. Now for right subtree 15, 4, 9. So this belongs to right subtree. So now we will use this thing. Okay. So this is the in order. This is the in order. Initially in order was 3, 7, 5, 6, 11, 2, 15, 4, 9. And what was level order? Level order was 2, 7, 15, 3, 6, 9, 5, 11 and 4. So our starting index of in order was 0 and it was 8. So we have found our IDX at fifth index. So what our left subtree will be containing elements from 0 to fourth index, that is 0, 1, 2, 3, 4, and this will be containing index from 6 to 8. So this will be 6 to 8. So our new value of in order starting index and in order ending index are these. Now our level order for this, we'll find this thing. How we'll find this thing? See, we know that 3 is the we know that in level order, if we'll see 7, 15, 3, 6, see this is level order. So what we'll do, we will store this in order values in a hash set. Suppose this is our hash set and we'll store these values in our hash set. See what our next step is. Our next step is we will find the values from level order. We'll find the values from level order into this hash set and we'll divide our left level order and right level order. So this is left level order and here we'll find right level order. Okay, this is what we are going to do now. So we have stored our in order values in a hash set, or we can say in a set. Okay, so what we'll do, we'll search the values from level order. See, we'll not search for 2 because we know 2 is the root value. That is the first value in level order is the root value. So we will not find this value. Okay, so we'll start from 7. We'll search for 7. Is 7 present in hash set? Yes, it is present. We'll remove from here and we'll add to our left order. Okay, now we'll search for 15. Is 15 present in our hash set? No, 15 is not present in our hash set. We'll add this 15 into our right level order. Okay, and now we'll search for 3. Is 3 present in this hash set? Yes, it is present. We'll remove from here. We'll add into this left. Okay, now we'll remove we'll search for 6. Is 6 present in hash set? Yes, we'll remove 6 and we'll add in left level order. We'll search for 5 now. We'll search for 9 now. Is 9 present? No. We'll add in right. We'll search for 5. Is 5 present? Yes, we'll remove 5 and add it to left level order. So we'll search for 11. Is 11 present? Yes, it is present. We'll remove 11, add to left. We'll search for 4. Is 4 present? No, 4 is not present. We'll add this 4 into our right level order. Okay. So till now, our Inorder starting index is 0. Inorder ending index is 4. In this side, Inorder starting index is 6. Inorder ending index is 8. Now we'll again do the same thing. So this will be our root value. This will be our root value because first value at level order is always our root value. So root for this will be 7 and here root will be 15. So here root value will be 15. Now again we'll do the same thing. We'll search for 7 in our Inorder. Where we'll find this 7? We'll find this 7 in index 0, 1. So we'll find this 7 in index 1. So our next ISI value will contain 0, comma, IDX minus 1. That is, this is IDX. That is IDX minus 1. So this will contain 0, comma, 0. So in this side, it will be IDX plus 1. That is, this is IDX. IDX equals to 1. So this is IDX equals to 1. And here IDX was 5. And now we'll add 1 to our IDX value, that is 2, 3, 4. 2, 4. So now again we'll do same thing. We'll create a set. We'll add the Inorder elements. What is the Inorder element? In this, we'll divide from here. So this will be containing 3. This Inorder will be containing 3. And here Inorder will be containing what? Here Inorder will be containing 5, 6, 11. Okay. 5, 6, 11. Now we will find left level order and right level order. So left level order and right level order. So we will add this 3 and we'll search from level order. We'll not search for 7 because 7 is the root. We'll search for 3. Is 3 present in hash in this set? Yes, present. Remove and add to our left level order. Is 6 present? No, add to right. Is 5 present? No, add to right. Is 11 present? No, add to right. Okay. So till here we have done. Now what we'll do? We see here indexing is equal and we have only one element in our level order. So now we will not make any calls. But here we have indexing from 2 to 4. Now what we will do? This will be our root value. So our root is 6 over here. So our root is 6 over here. Our root is 3 over here. Okay. From 6 we will search in this. We will find this 6 at IDX equals to 3. So we will divide from here. So this will be ISI, that is 2, comma IDX minus 1, that will be 2. So this will be IDX plus 1, that is 4, comma IEI, that is 4. So this will be 4. So our Inorder will contain 5 and our left and here also our Inorder will contain 11. Okay. And now here also left level order will contain 5 and right level order will contain 11. Now here we will do the same thing. We'll search for root, that is 15 in order. So we'll find this 15 in IDX equals to 6. Okay, so IDX equals to 6. So we will divide this thing. Firstly, we will create a set. We will add this in order 15, 4, so we have found our left and right from here, so there is no need to create set again. So this we have done. Now we'll search for 15. Now we'll make, we have found this 15 at IDX equals to 6. Now we will make our ISI and IEI. ISI will be 6 itself and IEI will be IDX minus 1, that is 5. Okay, and here our ISI will be 7 and IEI will be 8. So here what is happening? ISI is becoming greater than IEI. So this is the condition where we have to simply return null and attach that null to its. Now in this side, our in order will be 4, 9. So now again we'll create a set, and the set will contain before this IDX value, elements before this IDX value. So before this IDX value there are no elements, so this will be empty. So we will check in empty set. We'll search for 9. So for 9, this right level order, for 9 this will be coming at right level order. For 4 this will be coming at right level order. So now again this will be our root, 9 will be our root, and we'll check for 9 in our in order, and our in order will be having at IDX equals to 8. Okay, so now again for this value, our ISI and IEI will be 7, and ISI will be 7 and IEI will be IDX minus 1, that is 7. And this side ISI will be IDX plus 1, that is 9, and IEI will be 8. So here ISI is greater than IEI, so we'll simply return null. But in this side the in order will be 4, the in order will be 4, and the level order will be 4. So ultimately our tree will look like 2 having node 7, 7 having node 15, sorry, this, and 7 having left child as 3, 7 having right child as 6, 6 having left child as 5, and having right child as 11, 15 having right child as 9, and 9 having left child as 4. So this is how our tree will look like. So let's code for this thing. So this is our function build tree, and we'll be working on it. Firstly we'll put the size, we'll find the size of our level order vector, and we'll be calling the function build tree, passing the in order, and in order starting index, that will be 0, and in order ending index, that will be n minus 1, and level order. So create the function, change the parameters. Here will be int starting index of Inorder and ending index of Inorder. So come inside this function, and our very first work is to put the base condition. If ISI is greater than IEI, then return null. Then extract the root. What will be the root? Root will be the element that is node at first index, that is 0th index of level order. So then we will put the condition if level order dot size equals to 1, then return root. See, there were two base conditions when we were doing the dry run. Then there were two base conditions. So this was a condition if ISI is greater than IEI, so we have returned the null. And if the size of Inorder was 1, here the size of Inorder was 1, so we have returned the root. So this thing we have done. Now we will search for the root in our Inorder. So if value of root not equals to IDX, and what will be the IDX? So IDX will be initialized with ISI, that is starting index of Inorder. Then we will increment the IDX, and then we will create a set. We'll insert the elements in our set. For that, we'll start a loop from I equals to ISI till less than IDX. IDX I plus plus. We'll insert into the set. So what we have done over here is we have created the set, firstly the empty set, and we have added from 0 to IDX minus 1, that is less than IDX, that is 0 to 4. So for elements from 0 to 4 in our Inorder, we have inserted in our set, that is 3, 7, 5, 6, 11. This thing we have done. Now we'll create the left level order and the right level order. So left level order of size set of size equals to size of set, and same thing we'll do for the right level. This will be right level, and here the size will be, firstly we'll extract the value of n, that will be IEI minus ISI plus 1. This will be n minus size of set. Okay, so we have created the left level order and the right level order. Now we will insert in this left and right level order. So how we'll do this thing? We'll start a condition, we'll start a for loop. That loop will check from 1 to less than size of level order. Why we have started from 1? Because at I equals to 0 we have our root. At level order of 0 we are having our root. So we won't be checking for the root value. We'll be checking from I equals to 1. We'll find in our set for level order of I. If we'll find this in our set, then we have to add that in our left level. Add that nodes in left level at index. So we will start our index from 0, right index 0. So we will insert in left index else we'll add in right level. So this is right level indexing RI plus plus. So till now we have inserted the we have created our left level order and right level order. Now we will make recursive calls. For left, build tree, pass in order, and ISI value will remain ISI and IEI value will become IDX minus 1, and level order will pass. So in place of level order we'll pass the new L level order. So L level. Same thing we'll do for the right call. This will be R level and ISI value will become IDX plus 1 and IEI value will remain IEI. This will be right call. Then we'll return root. So let us compare line by line. So I hope it is visible to you. See what we are doing in this. See what we are doing. Firstly, we are checking the condition, base conditions, and we are creating a root. What is the root? Root is the node at 0th index of level order. So 2 is the root. Okay. Now our next step is we have checked the base conditions, and then our next work is to find the IDX. How we'll find the IDX? IDX is the index which is denoting the position of root in our Inorder. So what we'll do, we'll find this root value in our Inorder. So while finding, we will find at this IDX. So IDX will be 5. Now what we'll do, we'll create an empty set and we'll insert the nodes from I equals to ISI, that is ISI is 0. From 0 to less than IDX, that is from 0 to 4, we'll insert in our set, that is 3, 7, 5, 6, 11, 0 to 4. So we have inserted in our set, and now we have created, we are trying to find the left level and right level, left level order and right level order. Size of left level order will be equal to size of set, and of right level order will be n minus size of set. That is, if the size of this is 5, then it will be 9 minus 5, that is 4. And our next step is we will insert the elements, in left level order and right level order. How we will insert? We'll start finding the elements from I equals to 1. So we'll not find for I equals to 0, because at 0th position there will be always root. So we need not to find the root value. So we'll start from I equals to 1 till the size of level order. So we'll find for 7. Is 7 present in set? Yes, present. Then remove from set and add it to left level. So we have added it to left level, and then if it is then we'll check for 15. Is 15 present in this? No, 15 is not present. 15 is not present, then we'll come in else part and we will add this 15 in our right level order. Okay, and then after iterating from 1 to last, that is size of level order, we'll construct our left level order and right level order. Now we'll make call to our left subtree, and what we'll pass in our left subtree? We'll pass Inorder, and ISI will remain ISI, and ending index will become IDX minus 1. How? Initially it was 0, ISI will remain ISI, and IEI will become IDX minus 1, that is 5 minus 1, 4. And here for right, ISI will become IDX plus 1, that is 5 plus 1, 6, and IEI will remain IEI. Okay. And talking about these base condition, when we will jump at this position, then see, level order dot size equals to 1. Level order dot size equals to 1. That is, it is having only a single element. Then return root. And this condition is equals to ISI equals to IEI. Means ISI value and IEI value are also equal. If you can either put this condition or this condition. And where this condition is getting true, when for this case, like here there will be no node, so ISI value has become greater than IEI value, so we will return null, and this null PTR will get attached to left of this. Okay, so now I hope you have understood this thing. Now let's run our code. So there's some error, unordered set, line number 34, if set dot find level order of I not equals to set dot end. Okay, over here will be bracket so before semicolon before line number 53. Okay, so our output is correct. Let us submit it. Check all the test cases are passed. Okay, so all the test cases are passed. I hope you have understood the question and the solution. And so that's the end of our video. We'll be meeting in another video with another question. So thank you for watching.